I'm going to tell you something that will blow your mind. See this beautiful code written on the screen? Yeah, that is actually real code, and it's written in Ruby. So this talk will not be useful, but it might be fun, and you'll probably learn something new. So enjoy. There are a couple of esoteric languages out there, languages that use the minimum possible number of characters to get a Turing complete language. And I figured if someone did it for JavaScript, why not Ruby? So I wanted to create a language that is Turing complete. It works as syntactically valid Ruby. There are no alphanumeric characters, and there are as few characters as possible. Okay, that's our goal, and so I created BrainRuby. Let's write a program in BrainRuby to show how it works. The program is going to do that. It's just going to puts. And here's how it looks in BrainRuby. And I know that's a little bit overwhelming, but we're going to break it down, and you'll see how it works. The first thing to know is that in Ruby, if you have an empty string and you shovel a number into it, it will convert that number to the corresponding character and add that to the string. So for example, if you shovel the number 65 into a string, the capital letter A, its character code is 65, and so the capital letter A will be added to the string. So if we take these numbers and shovel them onto a string in that order, so we'll get puts, because those are the character codes that correspond to PUTS. Now let's say we replace each number with 1 plus 1 plus 1 plus 1, etc. until we get to the right number. So this is the same as before, just written as 1 plus 1 all the way down. And we still get puts, it still works. Here's the next tidbit. The global variable $$ in Ruby will give you the current process ID. So it'll be some probably large number, and it'll be different every time, so it doesn't seem useful, right? But thanks to our good friend math, $$ over $$ will give us 1 every time. So if we replace every one with $$ over $$, then we get something that looks like that, and it will still give us puts. So with that, we can generate any string. We have not used any alphanumeric characters. But how do we go from there to a running Ruby program? The answer is we have to put it inside of this template, and I'll explain to you. This looks like gibberish, but I'll explain to you how it works. So we start with $, which is a Ruby global variable representing standard out. Then there's a shovel operator. So if you shovel a string into standard out, you're basically telling Ruby you should output this string. It works basically the same as puts. Then come backticks, which start a new process on the command line, and they return a string. So we have a string that we can then shovel into standard out. We can interpolate inside of backticks, and so all we need to do now is give it a Ruby string. So we have our empty string, our shovel operator, and then we can feed in our program. So we generate a string, execute it using backticks, and we can send the output to standard out. Pretty simple. There's just one problem, which is that backticks do not execute in Ruby, they execute on the command line. So what can we do about that? Well, if you run Ruby on the command line with the -e flag and you pass that a string, it will run that string as Ruby code. So here's what we're really doing. We're doing something that's equivalent to puts. We're giving it then backticks, which will return a string, interpolating in a string, which gives it the command line program we want to run, which is Ruby -e, and then the content of our program. So when it's fully expanded, it looks like that, as you saw before. And if we want to go a little bit more complicated, well, here's a Hello World program written in BrainRuby. And this program is really tiny and you can't really see. This is FizzBuzz. And if you run this code, I promise you it works and it will output FizzBuzz, and it's awesome. So we have no alphanumeric characters. We only end up using 10 characters, and you can see all of them there. And it's completely legible, which was exactly the point. So that's awesome. I'm sure performance is great. I haven't really tested it, but I'm sure it's fine. We're only using 10 characters. So right now there's a little problem because you can't require other files written in BrainRuby, because if you require another file in BrainRuby, it will run Ruby code in a separate process, and so there's no shared memory space. You could put everything in one file, compile that to BrainRuby, and then run it that way. But if there's a way to require files written in BrainRuby, hopefully we'll come up with a solution for that. And then, I don't know, maybe there's a better way than to use 10 characters. Maybe there's even less characters that we could use with some clever hack. So keep calm and BrainRuby on. Don't forget that code can be just for fun. And that's me. I'm @AM Kaplan on the internet. You can find BrainRuby online. try it out, have some fun with it, contribute. And I was going to give this talk at RailsConf. I had stickers then. I still have plenty of stickers, so if you run into me at a meetup, at a conference, or just on the street, ask me for stickers, and I will give them to you. And your life will be even better because you will have stickers. That's about it. Have a great day.